Welcome to Astronomy Daily, the podcast that brings you the latest news from across the cosmos. I'm your host, Avery.
And I'm Anna. It's great to be with you all. In today's Reports Avery, we're talking about everything from rocket failures and delays to solving black hole mysteries and even filming movies in space.
That's right. It's a wild mix of stories today. Let's get right into it. First up, some unfortunate news from the private space sector in China.
Yes, this involves the Ceres 1 rocket, which is operated by a private company called Galactic Energy. They experienced their second ever failure during a recent launch from the Yellow Sea.
Right. So what went wrong?
Well, the initial part of the launch went smoothly. The first 3 stages of the solid propellant rocket performed exactly as expected. The problem occurred with the 4th and final stage.
The upper stage. So is shut down early?
Exactly. It experienced what the company called an abnormal performance and shut down prematurely. This meant the payload, 3 satellites, couldn't reach its intended orbit. They were unfortunately lost.
That's always tough to hear. You never want to see a mission fail. Do we know why the stage malfunctioned?
The company is investigating now. They've issued a public apology for the failure and are working on pinpointing the exact cause. It's important to note, though, this is only their second failure out of 22 missions.
That's a good point. A success rate over 90% is still very respectable, especially for a commercial launch provider. It just highlights how incredibly difficult rocket science is.
It certainly does. Now, from a setback in orbit to a major breakthrough in our understanding of the universe's most mysterious objects. Avery, you have an update on a so-called impossible black hole merger.
I do, and this is truly fascinating stuff. For a while now, astronomers have been puzzled by a specific gravitational wave event. It signaled the merger of 2 massive, rapidly spinning black holes, but the result was a black hole that, according to our models, shouldn't exist.
Okay, so why was it considered impossible?
It has to do with something called the upper stellar mass gap. It's a range of sizes, roughly between 65 and 135 times the mass of our sun, where we just don't expect to see black holes form from collapsing stars. This merger's resulting black hole landed right in that gap.
A real cosmic puzzle. So what was the solution?
The solution came from new, more complex simulations, and the key ingredient that had been missing was magnetic fields.
Magnetic fields. How do they change the equation?
Well, the new simulations included the effects of strong magnetic fields within the accretion disk. That's the swirling disk of gas and dust around the black hole. These fields are powerful enough to generate strong outflows, ejecting a significant amount of material out into space before it ever falls into the black hole.
Okay, so the black holes essentially started out much bigger, but the magnetic fields threw a bunch of their potential mass away before the final merger.
Precisely. By ejecting all that material, the final mass of the resulting black hole was reduced, allowing it to neatly fit into that previously unexplained mass gap. It's an elegant solution that shows our understanding is always evolving.
That's incredible. A great reminder that the universe is always more complex than our models first assume. Speaking of complex projects, there's a development regarding a highly anticipated new rocket.
That's right. We're talking about Rocket Lab's Neutron rocket. The company has officially announced that the rocket's first launch is now delayed until 2026 at the earliest.
No earlier than 2026. That's a significant pushback from their earlier targets.
It is. The company's CEO explained the reasoning, saying they want to ensure the first flight is fully successful. They're choosing to conduct more extensive testing on the ground rather than rushing to the launch pad and risking a failure.
That seems to be a smart, if costly, trend, prioritizing a successful debut over sticking to an aggressive schedule. A failure on the first flight can be devastating for a new launch program.
Exactly. The Neutron is a really big deal for them. It's their next generation reusable rocket designed to launch mega constellations and compete with the heavy hitters in the industry.
A huge step up from their workhorse Electron rocket.
It's a massive leap. This delay will increase the program's overall cost, as they noted, but Rocket Lab believes it's the right decision for the long-term success of Neutron.
Strategic patience. I think it's a wise move. Now, let's shift from launching rockets to filming on location. Way on location.
This is a fun one. A new film, a romantic comedy titled I See You, is aiming to be the first Western movie to actually shoot scenes in low Earth orbit.
Wow. So we're talking actors, directors, camera crews actually going up there?
That's the ambitious plan. It is, of course, a massive logistical challenge. To help them navigate it, they've brought on former NASA astronaut Scott Kelly as an advisor for the project.
Scott Kelly. That makes perfect sense. He spent nearly a year in space, so he'd know a thing or two about the realities of living and working up there. But wait, haven't we already had a movie filmed in space?
We have. You're absolutely right to point that out. The Russian film, The Challenge, already holds the title of the first feature film with scenes shot in space. They filmed on the International Space Station back in 2021.
So I See You is competing for the title of the first Western film to do so. That's a crucial distinction.
It is, but it's still an incredible undertaking. It'll be fascinating to see if they can pull it off. I can't even imagine what the insurance policy for a project like that looks like.
Astronomical, I'm sure. Okay, for our final story, we're looking a little closer to home at an asteroid that has a date with the moon.
Yes, NASA is currently tracking an asteroid named 2024 YR4. Now, before anyone gets alarmed, this object poses absolutely no threat to Earth. However, scientists have calculated there is a small but non-zero chance it could impact the moon.
The moon? And when is this potential impact supposed to happen?
The potential impact window is in 2032. Again, the probability is low, but it's significant enough that scientists are taking it very seriously as both a tracking challenge and a scientific opportunity.
A scientific opportunity. So I assume this is because we could actually watch it happen.
Exactly. We've never been able to study a lunar impact of this size with modern instruments as it happens. Observing the collision, the flash, and the resulting crater could provide a wealth of data about the moon's surface composition and the physics of high-velocity impacts.
That's right. It would be a planetary science goldmine.
And there's another important angle here: planetary defense. Tracking 2024 YR serves as a perfect real-world exercise for the systems we have in place to detect and monitor near-Earth objects.
So it's a dry run in a way, using a non-threatening object to make sure our systems are ready for one that might actually be a danger to Earth someday.
Precisely. It's a valuable chance to learn and prepare, all while potentially getting a front-row seat to a rare and spectacular cosmic event.
And that's all the time we have for today on Astronomy Daily. From black hole breakthroughs to cinematic ambitions in orbit, it's been another busy day in the world of space exploration.
It certainly has. We hope you enjoyed the show. You can find more details and links to all of these stories on our website at astronomydaily.io.
Thanks for tuning in. Join us next time as we continue to explore the final frontier. I'm Anna.
And I'm Avery. Clear skies, everyone, and keep looking up.